this video we're talking about the opposite of a number and negative numbers. And when we say the opposite of a number, all we mean is the number we start with multiplied by -1. So in other words, the opposite of 1 is -1. The opposite of 2 is -2. And the reason is because if we take 2 and we multiply 2 by -1, we get -1 times 2 is a -2. So the opposite of 2 is -2. In the same way, if we start with a negative number like -10, the opposite of -10 will be 10 because we took -10, we multiplied it by -1, and when we multiply these two negative numbers together, they cancel with one another and we get a positive 10. So the opposite of -10 is positive 10. Now we can use number lines to better see why this is the case. So we're going to use number lines to simplify some of these expressions. First, we're starting with the values 3 and -3. So these are just two individual values, 3 and -3. So if we want to graph or plot 3 on a number line, the fact that this is positive 3 tells us that we start at the origin here, 0, and we move to the right in the positive direction 3 units. So 1, 2, 3, and we get to this point here, 3. Because remember, when we have a number line, everything this way is positive, and everything this way to the left is negative. So when we see positive 3, we move to the right in the positive direction 3 units, 1, 2, 3, and we get the point 3. Now we know that the opposite of 3 is -3, and that makes sense to us because it's on the opposite side of the origin when we're looking at the number line. And if we want to take the opposite of 3, we just go to the other side of the origin, the same distance, and we get to this point here, -3. So 3 is the opposite of -3, and negative is the opposite of positive 3. We can also see that because if we break this -3 down into smaller pieces, we're starting with just 3, right? Ignore the negative sign for a second. We're starting with 3. If we graph 3 on our number line, we start at 0 and we move to the right 3 units. 1, 2, 3, and we get to this point here, 3. Then if we go and apply this negative sign, it tells us take the opposite of 3. So we start at this point 3 where we were before, and we jump to the left-hand side to find the opposite, and we get the point -3, and so that's how we end up with this total value here of -3. Now if we look at an expression where we have two values that are added together or subtracted from one another, here we have 1 plus a -2. So if we graph that along our number line, we start with positive 1, that means we start at the origin, and we move to the right in the positive direction 1 unit, and we get to this point here, positive 1. Now we want to add to that -2. We have 1 plus a -2. Well, this plus sign here basically tells us go in the direction indicated by the number that follows here. So this -2, the fact that this is a negative, tells us to move to the left. So this plus sign says, yes, move to the left. So -2, we're moving to the left from the point where we were. We go 1, 2 units to the left, and we get to this point here, which is -1. So what we know is that this is equal to -1, and that makes sense to us because we know that adding negative numbers is the same as subtracting. So this is really just 1 minus 2, which we know is equal to -1. On the other hand, if we say 1 minus a -2, this minus sign in the middle here tells us go in the opposite direction of what follows. So remember the plus sign said go in the direction of the number that follows. Since this is -2, it said yes, go to the left. Because we have a negative sign here and we have a negative number that follows, this -2 right here tells us move to the left. But the minus sign in the middle says go in the opposite direction. So instead of going to the left, we're going to go to the right. So what we're doing here is we start with 1. So that means we start at the origin, we move to the right 1 unit. So we go 1 unit and we end up here. Now if we look at this -2, this -2 would tell us move to the left 2 units. But the negative sign in the middle, this negative sign in the middle says go in the opposite direction. So don't move to the left, move to the right. So if we start at this point where we were, and now we move to the right 2 units, we get 1, 2, and we end up at 3. So we can say this is equal to 3. And that should make sense to us because we know that 1 minus a -2, when we have an even number of negatives to us because we know that 1 minus a -2, 3. And that should make sense to us, 3, so we can say this is equal to 1, 2, and we end up at opposite direction, so don't move to the left. Move to the right. So if we start at this point where we were, but the negative 1 unit, and we end up here. Now if we look at this -2, this -2 would tell us move to the left 2 units. But the negative sign in the middle, this negative sign in the middle says go in the opposite direction. So don't move to the left, move to the right. So if we start at this point where we were, and now we move to the right 2 units, we get 1, 2, and we end up at 3. So we can say this is equal to 3. And that should make sense to us because know that 1 minus a negative 2, when we have an even number of negative signs, they cancel with one another to become a positive sign. So 2 negative signs become a positive sign, and this is the same as 1 plus 2, which is equal to positive 3, and that's why we end up here at positive 3. Which is equal to become a positive sign, and this is the same to become a positive sign. So 2 negative signs, they cancel with one another to be negative 2 when we have an even number of negatives to us, because we know that 1 minus a negative 2, and we end up at 3, so we can say this is equal to 3. And that should make sense to us because we know that 1 minus a negative 2, when we have an even number of negative signs, they cancel with one another to become a positive sign. So 2 negative signs become a positive sign, and this is the same as 1 plus 2, which is equal to positive 3, and that's why we end up here at positive 3. So looking at a little bit more of a complicated example, here we have 3 plus 2 plus negative 5 minus 3. So again, if we start at the origin, we always start at the origin here, and we move 3 units in the positive direction. So we go 1, 2, 3, and we end up here at positive 3, and we've taken care of this part. We have plus, that means go in the direction indicated by the 2 here, and this is a positive 2, so we continue, we move 2 units to the right, and we end up at this positive 5 value right here when we add the 2. So this plus sign says go in the direction indicated by the negative 5. Negative 5 tells us to go to the left. So from where we were here, we go to the left 5 units. So 1, 2, 3, 4, 5. We end up back at the origin after we add a negative 5. And now we have minus 3. So the positive 3 here by itself tells us go to the right. But this negative sign here tells us go in the opposite direction of what's indicated. So instead of moving to the right, we move to the left 3 units, and we say 1, 2, 3, and we get to this point here, which is negative 3. So we know that this whole value is equal to negative 3, and that makes sense because if we just do the arithmetic, we get 3 plus 2 is 5, plus a negative 5 gets us back to 0, minus 3 gets us to negative 3. Now essentially what we learned from doing this is what we talked about in the beginning, that 1 is the opposite of negative 1, that 2 is the opposite of negative 2, and that 10 is the opposite of negative 10. So we know about opposite numbers now, but we also know that an even number of negative signs is equal to a positive sign, that an odd number of negative signs is equal to a negative. So in other words, if we're trying to simplify these expressions here, we have a negative, negative, negative 2, or a negative, 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 negative 2. What we can do is plot this on a number line here. So if we take this first example and we say that this is 0, this is positive 2, and this is negative 2, if we just start with the 2 by itself here, then we know we're starting here at positive 2. When we add to that our first negative sign, we're going to take the opposite. So in other words, negative 2 means the opposite of positive 2. So we come over here to negative 2. When we add on another negative sign, we're taking the opposite of negative 2. So we come back this way and we end up here again at positive 2. And then we take the opposite of negative, negative 2, or the opposite of negative 2, we come back this way, and we end up again at negative 2. So this is going to be equal to negative 2. On the other hand, if we look at this second example here, and we do the same thing and we say 0, positive 2, negative 2, we start with just the 2, so we start with just the 2. That starts us at positive 2 in the positive direction. We put a negative on the front, we take the opposite, that gets us over here to negative 2. we put another negative on it, we take the opposite again, we go back in the other direction, now we're over here at positive 2 again. We put another negative in front, that means take the opposite again, and you end up back over here at negative 2. And then we put another negative in front, and that means take the opposite again, and you end up back here at positive 2, so this is equal to positive 2. And what we can see then is that if we have an even number of negative signs, so in this case we have 4 negative signs, we want to cancel them in pairs, so 2 negative
waxaan dhahnaa ardayga positive integers wuxuu dhacaa dhanka midig oo macnaheedu yahay wuxuu dhacaa positionka marka ardayga buugeen wuxuu leeyahay positive integersku are placed waxaa la dhigaa on the right hand side of 0 waxay dhacaan dhanka midigeed ee tirada eber marka aad fiiriso ardayga hadda laynta kuu muuqda eber dhanka midig maxaa ka jira tirooyinka inta ka jira oo dhan ayaa waxay noqon doonaan positive integers marka examples of two positive integers tusaale ahaan aan qaadano inay yihiin +1 iyo +2 xagee dhigi doonaa marka arday waxaa dhigaynaa dhanka midigeed ee tirada eber kuwan ayaa waxay noqonayaan positive integers which we usually write as 1 and 2 respectively mar kasta waxaa iskaga qori karnaa calaamada positive in adeegsano qasab ma aha arday marka waa iska dhaafi karnaa calaamada 1 iyo 2 waa u qori karnaa marka arday waxaan filayaa inaad fahanteen positive integerska dhanka uu xigo ardayga aan u imaano negative integers arday negative integers maxay yihiin arday negative integers ayagana waxaa la dhigaa on the left hand side of 0 ayagana waxay xigsadaan dhanka bidixeed ee tirada eber negative integers waxa 1 iyo negative 2 waxa qori doonaa negative 1 iyo integers on the number line sidee ugu muujinaa abiyoonayaal number dhammaadka cashirkani waxaanu rabnaa inaanu gaarno kow inaanu kala saari karno ama aqoonsan karno sidee u nidaaminaa positive
Oh my god guys, welcome to another video. Today's video tutorial is going to be very helpful, but before we continue with the video guys, it's very notification and subscribe. So in today's video we're going to select the absolute value of both being 12, the same number but positive. But what about opposite numbers? What does that mean? We will learn that in this video. But when understanding what are opposite numbers, if our number is the same. Let's take a look at the number line. Whenever we have the number line, we have again 0 and we have positive numbers and we also have negative numbers to the left. Now, it's pretty important to remember that in the number line, we knew from before that 1 and -1 are both an equal distance from 0. And that's the reason that both their absolute values are the same, right? So we know that the absolute value of -1 is going to be 1, and that the absolute value of 1 is also going to be 1, because the absolute value of a number is that same number, and we don't take into account its sign, right? So we know that the absolute value of -100 is 100, and that the absolute value of 100 is still 100, because the distance from 0 is the same. So we're going to take a look at what it says when understanding the concept or the definition of opposite numbers. So they are in opposite positions whose distance to 0 is the same. So we have exactly the same thing. Whenever we have a number like 3, and we see the distance from 0, we know that the distance is going to be of 3 steps, right? And when we go also to 3, its distance from 0 is going to be also 3. What that means, guys, is that the absolute value of plus 3 is 3, and the absolute value of minus 3 is also 3. That means that they are away from 0 the same exact distance, meaning that the opposite value of 3 is minus 3. So the opposite value of 100 is minus 100. Do you see where I'm going here? Well, the opposite value of a number is going to be that same number, but the contrary sign, right? The opposite sign. So whenever we have a number like 100 and we want to find the opposite number, it's simply going to be that same number with the opposite sign. So for example, if we have a number like 29 or minus 29, the opposite of that number is going to be positive 29. And that doesn't even just work for normal numbers, it also works for any type of number, like decimals. 0.55, its opposite is going to be minus 0.55. 2/3, its opposite is going to be minus 2/3. Because the distance in the number line from 0 is still going to be the same one. So 2/2 and minus 2/2 are each going to be the exact same distance away from 0. So you just have to take that into account. Let's look at this. How do we even know if two numbers are opposite? Well, first of all, they need to have the same absolute value, as we saw before. And second of all, they have opposite signs, right? So if we have a number, it can be a fraction, like for example, 2 divided by 3. Its opposite is going to be minus 2/3. If we have a negative number, for example, minus 95.4, its opposite is going to be the same number, but the opposite sign. So in this case, positive 95.4. Because you can see that they have both checks. So they have the same absolute value. The absolute value of 2/3 is 2/3, and the absolute value of minus 2/3 is also 2/3. And the same thing goes for 95.4. And of course, they have opposite signs. So for plus 2/3, we have minus 2/3. And the contrary here, minus 95.4, the opposite being positive 95.4. What do I do with this information? Well, let's tackle a challenge. Okay guys, in this part of the video, feel free to pause the video and try solving these simple problems on your own. or try going back to seeing the concepts of opposite numbers and then try challenging yourself doing these problems. If you want to continue watching the video, let's begin now. Okay, so the opposite of the following rational numbers. Again, if we want to find the opposite number of 12, we just have to write the same number, which is 12, but in this case we have a positive 12, now we're down a negative 12. So negative 12 is the opposite of positive 12. For negative 34, the exact same logic. We write down the same number, 34, but because it was negative, now we write it down as a positive. So the opposite of negative 34 is plus 34 or positive 34. Now we have 81 divided by 133. Even if it's a complex fraction, we already know that it's positive, so the opposite has to be negative, and again, the same exact number. So the opposite of 81 on top of 133 is the same number with the negative sign. And the same logic applies to negative 2.09. So it's going to be positive 2.09. So guys, just remember, understanding opposite numbers basically consists on knowing the definition, knowing the concept of absolute value, and understanding that it's the same number but with a different sign. So guys, I'll see you on the next one. Bye.
Check out these other videos to improve your math skills and make sure
Oh math god, guys, welcome to today's video. In today's video we're going to be discussing about the concept of subtracting integers using the number line. If you find videos daily
with subtraction of integers using the number line. So let's begin. Two numbers I have to count. What if those two numbers are negative? Those are the questions.
Signs becomes a positive, two more negative signs becomes a positive, and we're just left with positive 2. An odd number of negative signs leaves you with a negative, so we cancel two negative signs. We're only left with the one negative sign, which can't cancel, so we're just left with negative 2. video, we're talking about absolute value, and the most important thing to remember about absolute value is that it just means distance from the origin. So I've got some examples here of the absolute value of different expressions. This first one is the absolute value of 2. So these two lines are called absolute value brackets or absolute value bars. And what this tells us is that we're taking the absolute value of whatever's inside them. In this case, the absolute value of 2. So all we want to do is look at our number line. We always start here from the origin at 0, and we have positive 2 on the number line. So we're just going to go over to positive 2, 1, 2, and we'll end up here. So how far is 2 from the origin? Well, it's 2 units away from the origin, so the absolute value of 2 is just 2, because remember, absolute value of something is the distance of that thing from the origin. If we want to take the absolute value of negative 2, we want to figure out how far negative 2 is away from the origin. So we start here at the origin, and we go to negative 2. So 1, 2 units to get to negative 2, so this is going to be equal to 2. In other words, whenever you have a value inside absolute value bars, the result is always going to be positive, because the absolute value bars just tell you to take the distance from the origin, and whether you go to the right in the positive direction or to the left in the negative direction, distance from the origin is always still going to be positive. Now what happens when we have an expression like this? We have 3 minus 4 inside our absolute value bar, so this is the absolute value of 3 minus 4. Well, we have to simplify what's inside of our absolute value bars first, so 3 minus 4 is negative 1, so this is going to be the absolute value of negative 1. And just as we did here with the absolute value of negative 2, we start at the origin and we want to go over to negative 1 like this. We moved 1 unit away, so that means that the absolute value of negative 1 is 1, because negative 1 is just 1 unit away from the origin. If we have the opposite of the absolute value of positive 4, well, we have to do what's inside the absolute value bars first. The absolute value of 4, or the distance of 4 from the origin, is just going to be 4, because we would start here at the origin and we would go over to 4, 1, 2, 3, 4 units to get to positive 4. So the absolute value of 4 is just going to be 4. So this part right here is going to simplify to 4. So what we're going to get is we're going to leave the negative sign, and then we're going to get 4 here. So it's still negative 4, because this negative is outside of our absolute value bar, so we have to evaluate the absolute value of 4 first. We know that that's just 4, and then we keep the negative sign out in front.
What is the absolute value of 5? And what is the absolute value of negative 8? The absolute value of 5 is 5. The absolute value of negative 8 is positive 8. The absolute value cannot produce a negative result. It will always produce a positive result, or if you have 0, it will give you 0. Now let's say if you have an equation, for example, the absolute value of x is equal to 7. What are the possible values of x? X can equal two things, 7 or negative 7, because if you plug these numbers in, the equation will be true. The absolute value of 7 is 7, so this works. The absolute value of negative 7 is also 7, so x could be 7 or negative 7. Both will make the equation true. So now how can we use this to solve a typical problem that involves an absolute value symbol? So let's say if we have the function, the absolute value of x plus 2 is equal to 9. How can we solve this equation? Well, the first thing you should do is write two equations. The original one, and another one where the inside function is equal to negative 9 instead of positive 9, and solve for both. So in the first one, we can see that x can be equal to 7. And for the second one, x is equal to negative 11. So these are the solutions. Find the value of x given this equation. So just like the last example, let's set 2x minus 5 equal to 1 and negative 1. So first let's add 5. 1 plus 5 is 6. And then let's divide both sides by 2. So x is equal to 3. And in the other example, let's add 5 to both sides. Negative 1 plus 5 is 4. And then divide by 2. X is 2. So if you check the work, you can see that it's going to work out. So if we plug in 2, 2 times 2 is 4. 4 minus 5 is negative 1. The absolute value of negative 1 is 1. So the equation is true. Now, if we plug in 3, it should also work. 2 times 3 is equal to 6. 6 minus 5 is 1. The absolute value of 1 is 1. So that works. Now what about this one? The absolute value of 5x minus 1 is equal to negative 2. What's the solution? The absolute value function can never equal a negative number, so there's no solution for this particular example. It can only equal 0 or 2 times 2 is 4. 4 minus 5 is negative 1. The absolute value of negative 1 is 1. so the equation is true. Now, if we plug in 3, it should also work. 2 times 3 is equal to 6. 6 minus 5 is 1. The absolute value of 1 is 1. So that works. Now what about this one? The absolute value of 5x minus 1 is equal to negative 2. What's the solution? The absolute value function can never equal a negative number. So there's no solution for this particular example. It can only equal 0 or a positive number. Now let's try one more example for this particular lesson. Find the value of x. Now, what you don't want to do is write this equation on the left is equal to 7 or negative 7. First, you want to modify the equation. You want to get the absolute value function by itself. So let's add 2 first. So we're going to get 9 on the right side. Next, let's divide by 3. Now you want the absolute value symbol by itself on one side. Once you have it at this point, now you want to write 2 equations. So the first one's going to be x minus 1 is equal to 3, and the second, x minus 1 is equal to negative 3. So if we add 1, x is equal to 4, and if we add 1 to the other one, negative 3 plus 1 is negative 2.